Hello, welcome back. As I promised you during my last video, I'm gonna show you how to solve, let's say, this tricky exponential equation, and I'll try to show you a couple of tricky things which are quite useful, I guess. So I'm gonna solve this equation like, let's say, 2 times, and I'll explain the advantage of each solution, though they are quite similar. Okay, so as you can see in this equation, we want to come, and this is the main goal when we are solving any exponential equation, to come to the equation where we will have the same basis, and then we can simply say if the bases are the same, then the exponents must be the same, so that the equation is really true. Okay, so you can see in this equation again we have like really 2 bases. The first one is number 5 and the second one is number 3. Okay, so what we want to do, the first is we want to rearrange our equation so that we have the expressions with the same basis on the same sizes of the equation. So we simply take away 43 times 5 to the power of x plus 4. As well, we do add up 3 to the power of x plus 7. Okay, we want to move this one here, that's why we do the addition, and we want to move this one here, that's why we do the subtraction. Okay, so if we do this operation, x 5 to the power of x plus 6, take away 43 times 5 to the power of x plus 4 is equal to 3 to the power of x plus 7 minus 19 times 3 to the power of x plus 5. Okay, as you were probably taught, and as I have shown you before, the clever idea is to use the factorization method, because as you can see in this term and in this term we have the same factor, but maybe you don't see it, so I will simplify. It's gonna be 5 to the power of x times 5 to the power of 6. We used, I just want to note or stress that we used this formula, but we used it like other way around. So we went from the addition of the exponents to the multiplication of each exponential. Okay, so then it's gonna be 43 times 5 to the power of x times 5 to the power of 4 is equal. We do the same thing on the right side. 3 to the power of x times 3 to the power of 7, take away 19 times 3 to the power of x times 3 to the power of 5. Okay, now we know, we can see, and this is the thing we always do anyway. Also with the linear equation, we try to isolate the x's. So in this case it's going to be 5 to the power of x times 5 to the power of 6, take away 43 times 5 to the power of 4 is equal to 3 to the power of x times 3 to the power of 7, take away 19 times 3 to the power of 5. Okay, now if you have a look on this equation, I think it's easy to understand, and if you have watched my previous video, you know that we want to divide both sides by the expression x, 3 to the power of x, and then with the expression in these parentheses. There is one, let's say, like, I don't want to say that the problem, but before we do, it's a good idea and clever idea to calculate the number, the value of the parentheses. But in this case, I'm not quite okay, because I don't use calculators. I'm not quite okay to find out what is the value of 5 to the power of 6, but I prefer, and as you can see, we also have here some kind of common factor. So and we have the common factor like here, so we can simplify the expressions in the parentheses. So 5 to the power of x times 5 to the power of 4, okay, let me use this kind of brackets, times, here we will remain by 5 to the power of 2, take away 43, and these are quite nice numbers, 3 to the power of x times 3 to the power, and you will understand later on y to the power of 4, okay? And the reason for this, please, is that here we have the power of 4 and here we have the power of 4, and we will become to the fraction 5 over 3 to the power of x. So that's why I'm doing the thing like this. But you are okay, and it's okay if you take really like the common factor from these two, which is 3 to the power of 5. But as I want to teach you something like new and clever, I'm gonna do it like this. So then we will have like 3 to the power of 3, take away 19 times 3, okay, because 3 to the power of 4 times 3 is 3 to the power of 5, okay, and 3 to the power of 4 times 3 to the power of 3 is 3 to the power of 7. Okay, you can see that it's really necessary to understand and to know these facts, which I have listed on the right side on my video and the previous one as well. Now, if you have a look at this, you can simplify it a little bit more. So it's gonna be 5 to the power of x, 5 to the power of 4 times 25, take away 43 is negative 18. You can check it by your own if you don't trust me. 3 to the power of x times 3 to the power of 4 times, this is like 27, take away 57, which is negative 30. Yes. Okay, if you don't trust me, you can try by your own. So you can see, evaluate these numbers is much easier than evaluating 5 to the power of 6 and so on. And especially it's gonna be like really clever idea. So now I think we are ready to do our, let's say, last step to see what the result of the equation is. So we simply multiply both sides by 1 over 3 to the power of x times 1 over 5 to the power of 4 times negative 18. Okay, if you want to play around really with the big numbers and then simplify them, you can do it, but it's really not a good idea, and it's definitely not a clever idea. So if we apply these operations, then it's gonna be on the left side of our equation 5 over 3 to the power of x equals, which is nice. And if you remember, and if you watch my previous video, you will see and understand why. And here we will have 3 to the power of 4 times negative 30 over 5 to the power of 4 times negative 18. And here you can see and understand why this was really the clever idea. And if you are still not quite okay and don't understand why this was really a good idea, you will see later on. If you have a look on this fraction, you can simplify these two numbers, and negative number over or divided by negative number is gonna be positive. So I will simplify this like 3 over 4 times 5 over 4 times, and you just don't simplify it because of the negative values, but you can also do it like dividing by the greatest common divider, which is a number 2 is 15, and then number 6, yeah, the greatest common divisor is number 6. So 30 divided by 6 is 5, and 18 divided by 6 is 3. Now if you have a look on this one, you can see very easily that 5 can be simplified with 5 from here, so the exponent now won't be number 4, but it's gonna be number 3, and the same applies here. You simplify this one and the exponent is gonna be number 3. So after doing these simplifications, after simplifying this super special tricky fraction, you will come to the equation 5 over 3 to the power of x is equal 3 over 5 to the power of 3. And I'm pretty sure you can already, if you have seen my previous videos, you can see very easily. Let me just scroll a little bit up so that I can show you. This expression can be written by using this formula, and this is really equal to 5 over 3 to the power of negative 3, and we finally came to this one. So we have the same basis and that means our x is equal to negative 3. It would be really nice to make the check. You can do it by your own. It's not very complicated, I promise. So our conclusion is that the set of our roots is one element set and it's number negative 3. Okay, so this was one and really, I would say, a little bit complicated solution, because you can solve this equation even easier way. If you are willing to see the procedure, stay with me. I have to delete the very beginning of my solution because my solution is gonna be a little bit different, and I think I can, yep, I can only stay with this one, so I don't need this anymore. I don't need this one anymore. I don't need this one, and neither this one. Okay. So let's see what is the tricky thing behind this solution. As you can already see, and I basically used it before because I didn't write 5 to the power of x minus 5 to the power of 4 as numbers, but instead of that I said to evaluate this expression, numerical expression, it's easier to do 5 to the power of 4 times 5 to the power of 2, take away 1. Okay, I'm pretty sure without calculator this is gonna be, in my opinion, much easier than to evaluate 5 to the power of 5 times 5 times 5, though I'm pretty sure some of you can see that this one is 5 to the power of 3 and 5 to the power of 3, but this is not this is the thing, but we will apply this on expressions being as exponents, and we'll be looking, what did I do here? I found the greatest number I can factor the expression then. Okay, maybe it's not quite clear now, and I'm pretty sure it's gonna be more clear if I'll do the thing I want to do. But before we start, I'm gonna move again the same basis on the same sides of my equation. So take away 43 times 5 to the power of x plus 4 and plus 3 to the power of x plus 7, which basically will be 5 to the power of x plus 6 minus 43 times 5 to the power of x plus 4 is equal 3 to the power of x plus 7. Take away 19 times 3 to the power of x plus 5. Okay? No. What is the clever idea here is that this expression and this expression are like, they have the common factor. And what do you think is the common factor of these expressions? Yes. Okay, if your answer was like this, and I will explain in more details that this can be rewritten as this one, take away 43 times 5 to the power of x plus 4. Why did we do so? Because you can see here is my exponent and here is my exponent as well. So this is gonna be the common factor, and I will write it in more details later on. And as you have seen in the previous example, it's a really good idea, because we know what we are going to do with the equation, to have the same exponent here. So it's gonna be x to the power of 4 plus 3. Okay, let me do it another way around like I did it before. So x plus 4 plus 3, take away 19 times 3 to the power of x plus 4 plus 1. Okay, and let me put the brackets here again as I did on the left side, so that you can see what I did. Okay, so basically what will we get is 5 to the power of x plus 4 times 5 to the power of 2 minus 43 times 5 to the power of x plus 4 is equal to 3 to the power of x plus 4 times 3 to the third power, take away 19 times 3 to the power of x plus 3 times 3. And I'm pretty sure you can see now the common factors on the left side, as well the common factors on the right side, and using the same procedure as we did till now, you can see that this is going to be 25 take away 43 is equal to 3 to the power of x plus 4 times 27 take away 57. Okay, and I'm pretty sure you can see that this is a really like clever idea, because now let me simplify this. This is gonna be 5 to the power of x plus 4 times negative 18 is equal to 3 to the power of x plus 4 times negative 30, and this is something we have seen before, but in a more complicated way, because there were including these exponents and bigger numbers. So now what do? We simply apply both sides by 1 over 3 to the power of x plus 4 times 1 over negative 18, because we want to have x's on the left side and just numbers on the right side. So then we will have the equation like 5 over 3 to the power of x plus 4 is equal to, and negative 30 and negative 18 is gonna be positive number, so I will get rid of the minus signs, and we will have something like this. We already know that this can be simplified, and the numerator and denominator could be divided by number 6, so it's gonna be it's gonna be 5 over 3. Okay, now 5 over 3 is of course to the power of 1, which means we have the same basis, and it means if we have the same basis, then the exponents must be equal. So we will come to the equation x plus 4 is equal to 1, which means x is equal to negative 3, which is the same result as we get during our previous solution. So what is the conclusion here? This equation looks a little bit more complex, but the procedure is the same as it was for the easier one, and the only thing here is that there are like scary numbers, but if you are familiar with the powers and the exponents, then it is really gonna be like simple solution. Now maybe you are scared of doing the check of this equation for our calculated x. And as I would need to have more space, let's do it. So this is my solution, this is my equation. Let's do the check, and you will see that this is nothing like really hard. So left side for x being -3 is equal to 5 to the power of -3 plus 6. Take away 3 to the power of -3 plus 7, which is equal to 5 to the power of 4. Take away 3 to the power of 5 to the power of 3. Take away 3 to the power of 4, which is now you can use this really like simple thing. So it's gonna be it can be like 5 to the power of 2 times 5, which is 25 times 5, but maybe you are familiar with the 5 to the power of 3, that it is equal to 125. Take away, this is again 3 to the second 3 squared times 3 squared, which is 9 times 9, which is take away 81. If you do this subtraction, you will come to the number 44. So you can see this was really easy. Now let's do the check for the right side for x being -3, which is 43 times 5 to the power of -3 plus 4 minus 19 times 3 to the power of -3 plus 5. As you can see, these are gonna be really simple numbers, because it's gonna be 43 times 5, take away 19 times 3 to the power the second 3 squared. And then these are numbers like 215, it's 215. Take away 19 times 9 is 90 plus 81 is 171, which is 44. Okay, we are done. So the solution is correct. The check is quite simple, and you can make the conclusion that the set of the roots or of the solutions is one element set, and it is number -3. Okay, I hope this video will be helpful for you, though this example or this equation is quite, let's say, tricky, and you should be able to apply a couple of rules or things or facts if you want to. But still, this is something you can calculate by your own. So thanks for watching, and see you during our next video about solving exponential equations by substitution. Bye.